We're looking at household circuit notes again, and we did the first 2 pages, so we're going to start this on the 3rd page. Grounding is another safety feature. Electricity is always seeking the ground. Last year you might have learned about lightning, and it was looking for the easiest path to the ground. It goes through air, and then it may be going for a tall object or something out in the middle of an open field, that kind of thing. Well, in the house we have electrical devices, and if something goes wrong, electricity is still going to be seeking a path to ground. So let's say you have a device that has a metal cover, and that metal cover is touching a hot wire. If you touch the metal casing, all of a sudden you're going to be the easiest path to ground. And if electricity goes through you, you're in trouble because you have a nervous system that is electrical in nature, and it could do something like shut off your heart. So it's very important that we have this safety feature so you are not the easiest path to ground. The path will go from an appliance grounding socket to a grounding wire to a service entrance panel, so that's why you'll see that 3rd wire on many circuits, and then another wire goes out to a grounding rod that should be driven into the ground outside your house. GFCI, sometimes called a GFI, is a ground fault circuit interrupter. Now, a circuit breaker takes time before it shuts off because the bimetallic strip has to heat up enough to bend to shut it off. In the meantime, current could be flowing, and that might be enough to kill someone. So a GFCI examines the current coming in and going out, and if those currents don't match, it shuts off immediately. So what it's doing here is if you were, say, deciding to have a nice bath and that's where you want to have toast and your toaster's set there, and all of a sudden the toaster falls in, with a GFCI you might survive. It may be able to shut off the current fast enough so that you don't get electrocuted. So GFCI is used in circuits near water, and often those in a home or bathroom, kitchen, or perhaps outside. Polarized plugs and outlets, we're going to look at another video on these things shortly. But polarized plugs have 2 prongs. They have a wide and they have a narrow. The wide connects to the neutral wire, and the narrow connects to the hot wire. So that's why you can see it right here. And what this is, it means it can only plug in one way. Also the wide one, if things are wired properly and you put something in there, you should be okay. But if you put a piece of metal into the hot, you probably are going to be the easiest path to ground, and that's a problem. The other thing polarized plugs do is, since it can plug in only one way, for that device, it will make sure that you're farther away from touching something connected to the hot wire. Energuide labels are things that are put on appliances like a fridge, an electric stove, a dishwasher, clothes dryer, major appliances that are electrical, and it tells you the average number of kilowatt hours that device is likely to use in a year. So we definitely want to buy an appliance with a low Energuide number because it will use less energy and therefore be cheaper to operate. So we also want to buy things that are more efficient. And in the first section of energy, we talked about efficiency. And so that means we're getting more useful energy from our input. And you might have watched Electrojuice last year in Science 9. Safety first, make sure you respect electricity. Don't be a path to ground. All right, so that wraps up our first set of notes in the section.